Alright, this is Ken Rosever, and we're talking about expectation and variance of a random variable. In the last 3 videos I've been taking examples from the book, but in this example I'm going to use ones from Alex. This isn't the easiest concept because it's very calculation intensive, and there's a lot of places where if you miss a plus sign or a multiplication sign, you can mess up. So be very careful, double check yourself. First thing they're going to ask you is to find the expectation, or E of x. E of x is simply the mean. It's the sum of the values times the probability of that value. So it's basically this guy times this guy over here. It's the value times its weight. You can think of the probabilities as being weights, because indeed they are. If you think of there being 100 trials, and 15 of them would come out like this, 10 like that, 30 like that, and 45 like that. So you can think of it like that, just as we did for calculated weighted means. We did the weight times the value. You're going to do the same thing here. So in your calculator, it shouldn't take you very long to multiply these guys out and add them up. I'm going to do it real quick. Here we go. So I have 40 times 0.15 plus 50 times 0.1 plus 60 times 0.3 plus 70 times 0.45. And you should pause the video and see what you get. I got 60.5. So that is our expectation. I will put that right here. The mean is 60.5. So if this were a class of students, and this were a test where 70 was the highest and 40 happened to be the lowest, I would have 45% of the students got 100, 30% of the students got somewhere in the 80s, right? 15% of the students got a 40, which is like a high F. Anyways, so on average, the students got around a 60.5. 60.5 would be like a high B if you're doing it out of 70. Okay. They're also going to ask you the variance. Now, there's 4 different formulas that you'll find if you look around for variance. 2 of them in your book, and then 2 of them in Alex. So let me show you all of them and show you how they compare and why it's okay that they look different. The variance formula you'll find in Alex looks like this, and it's pretty involved. It says the variance of a discrete random variable x is the weighted mean of the squared deviations of the possible values of x from their mean. Wow. All that is to say, you take the differences, you square them, and you multiply them by the weight. Okay, so this right here, we know e to the x is mu, right? So this thing right here, and they're being very formal in their notation using the indexes, but you don't have to be that formal. You're going to go from 1 to n, you're going to add up all the values. So it's the sum of the differences squared times their probability. These are their probabilities, and the probabilities change according to which value you're on. So these are exactly the same thing. Okay, these 2 formulas. This one here comes from your book. It's on page 270. It's the one that is not in the box. It's the one I use more often. Okay, on this one, what do? You take the differences, you square them, you multiply them by the probability, which is acting as the weight, and then you add up all those values, all those products. Another way you can see the formula is right here. This is the alternative formula given in Alex. So this is their alternative formula. and it corresponds to this shortcut formula given in your book. Now you'll notice here they have e to the x. Let me highlight that. I'll use green. Or not e to the x, e of x, right? The expectation. Well, we know the expectation is the same as the mean. Notice they're finding the expectation and then squaring it. Here we find the mean and then we square it. So that's the same thing. Now this is new over here. I had never seen this before I looked at Alex and saw it in there. It says e of x squared, but we can quickly figure that out because we know what e of x is. E of x is the sum of the x's times the probability. So e of x squared, just change the x into an x squared in the formula. And when you do that, when you know that the expectation of x squared would be the sum of the x squareds times their probability, you see that this here corresponds to this down here. Okay? The sum of the x squareds times their probability. So these two things in blue match. And it's really up to you which way you want to do it. Either way will come out to the same answer. It's just a question of which one you think is easier. So I am going to do it both ways if I have time. Do I have time? I think I do. I will do it according to the first way first. My first way is to find the differences, square them, and multiply them by the probability. So the first one I'm going to use, or the first formula I'm going to be using, let me write it down, is that the variance is equal to the sum of the x minus mu's squared times their probabilities. So the first thing I got to do here is make a column of x minus mu's. X minus the mean. So this is 60.5, this is 40, so this is 20.5. It's actually negative, and I'll put that in. This is 10.5, it's also negative. This is 0.5, and this is 9.5, and it's positive. But we know all those negatives are going to go away because in the very next column, what do? We square it. So it's going to be 20.5 squared. And what are we going to do with that? We're going to multiply it by its probability. So times 0.15. We're going to do 10.5, and I'm leaving off the negatives because they don't really matter, times 0.1. We're going to have 0.5 squared times 0.3, and then 9.5 squared times 0.45. And let me calculate that real quick. I'm not going to do all the intermittent calculations. I'm going to do one big calculation in my calculator. So 20.5 squared times 0.15 plus 10.5 squared times 0.1 plus 0.5 squared times 0.3 plus 9.5 squared times 0.45. Enter. And my answer is 114.75. So when I add all those up, I get 114.75. Now let's do it the other way. The other way, oh, we can see it. It's right here. It says sum the x squareds times the p of x's. So do I have an x column? I do. Let's have an x squared column then. So it's going to be 40 squared, 50 squared, 60 squared, 70 squared, and I'm going to be multiplying all those by p of x. So times, let's use parentheses, 0.15, 0.10, 0.30, and 0.45. And once I get that sum, I'm going to minus 60.5 squared. So when I get all that, I'm going to subtract 60.5 squared from it. Let's do it. So in my calculator, I have 40 squared times 0.15 plus 50 squared times 0.1 plus 60 squared times 0.3 plus 70 squared times 0.45 equals. And you don't have to hit equals there, I'm just doing it. And I'm going to minus from that 60.5 squared. So minus 60.5 squared equals 114.75. So you get exactly the same answer doing it using the first formula as you do using the second. Okay? So, but you do have to be careful because it's easy to mess up. The first time I tried this, I wrote 62.5 on mistake, and so I got it wrong. Anyways, I think that's all I have time for in this video. Bye.